This is Grade 6 Math, Chapter 1.4, Squares and Square Roots. There are two new ideas in this chapter. The first is to find a square of a number, and the second is to find the square root of a number. Let's get started. Let's begin by finding the square of a whole number. So we'll start by imagining we have a square with side lengths all being equal, since it's a square, at 8 centimeters. To find the area of this square, we would take the length times the width, correct? Which would be 8 times 8. So 8 centimeters times 8 centimeters would give us an answer of 64 centimeters squared. And this is the area of our square. In this example, 8 times 8 can also be called the square of 8. We could write it as 8 times 8 equals 8 to the second power, or 8 squared. The number 2 in 8 squared is called the exponent. So this is called our exponent. And this 8 is called the base of our expression. So the square of a whole number is called a perfect square. Bet you can see why that makes sense, right? We're simply taking an imaginary square. We're taking the number times itself to find the area of that imaginary square. And that gives us our perfect square, whose answer is 64. Now let's find the square of 5. We can write this as 5 squared. So again, 5 is our base, 2 is our exponent. And when we see a base with an exponent, what the exponent is telling us to do is to take the base times itself, the number of times the exponent tells us. So in this case, we're going to take 5, our base, and we're going to multiply 5 by itself 2 times, because that's what the exponent is telling us to do. And now we solve. 5 times 5 equals 25. So the square of 5 is 25. If you want to think about that imaginary square again to help you visualize it, you most certainly can. It's telling you you're making a square that's 5 units long on each side. Then you're going to find the area of that square by taking the height times the width, 5 times 5, and finding an area of 25 square units. So you're finding the square by finding the area of this square. Try these 4 problems on your own. Record your answer in your homework notebook. Find the square of each of the following numbers: 2, 6, 9, and 11. You may use whichever technique you prefer. You may either draw the square and think of each side length in this manner, or you can write it as a base with an exponent, 2 raised to the second power. Press pause. I'll be here waiting when you get back. Now let's explore finding the square root of a perfect square. We're going to begin with a square. Once again, all of the sides will be equal length. And we know that the area of our square is equal to 9 centimeters squared. Okay, so what do we know about the area of a square? We know that length times length equals our area, correct? So in this case, we know that our length times our length is equal to 9, correct? Because we know that the area of our square is 9 centimeters squared. Please note that you read this centimeters to the second power as square centimeters are centimeters squared. So recalling your basic multiplication facts, you know that 3 times 3 equals 9. So the length of each side must be 3 centimeters. So in this example, 3 is called the square root of 9, because 3 times 3 equals 9. So we write this as the square root, it gets this really cool symbol, of 9 equals 3. So we read this sentence, this number sentence here is read as the square root of 9 equals 3. Please note that finding the square root of a number is exactly the inverse or exactly the opposite of finding the square of a number. When we're squaring a number, we're finding out what is the number times itself going to equal. When we're finding the square root, we're trying to decide what number times itself equals that number. Let's try another example. What is the square root of 100? Once again, you can use that square if it helps you to visualize how this process works. So we know that something times something equals 100 square units. Okay, 100 units squared. All right, so what times what equals 100? Well, my memory tells me that 10 times 10 equals 100. Therefore, the square root of 100 equals 10. There is another method that I'd like to show you, though, if you don't want to rely on your memory for your basic facts. You can also use prime factorization to figure out what the square root of a number would be. So let's factor 100. Let's see, we'll have 2 and 50, carry down our 2, 2 and 25, carry down those 2's so we don't forget about them, and 5 times 5. Okay, there's our prime factorization. 2 times 2 times 5 times 5. All right, so now to figure out what the square root would be, we need to look for commonalities in our prime factorization. Are there places where you can see pairs of numbers that match? Yes, we have a 2 times 5 and another 2 times 5. So using that commutative property of multiplication, meaning it doesn't matter in what order you multiply, you always get the same answer. We'll take 2 times 5 times 2 times 5. So 10 times 10 to get an answer of 100. So there's another technique if you would like to try using the prime factorization to find your square root. This method of prime factorization is much more efficient, especially if the number you're working with is unfamiliar or it's really large. You don't want to spend your time guessing and checking if you're working with a really big number. So I would recommend anytime you're dealing with a large number or a number that you don't immediately know the basic fact for, that you go ahead and prime factor. It's going to work much more quickly and efficiently than trying to use mental math or guess and check. Please finish up today's lesson by trying these 4 problems on your own. Find the square root of each number. Remember, you can use either technique. 1, you can use the remembered basic fact if it comes to you immediately. So I'm guessing most of you will recall that 1 number times 1 number equals 25 very easily. However, if it's more complicated, such as 196, you want to use the prime factorization technique to find the square root. All right, I'll see you tomorrow. We'll talk some squares and square roots, and I'm looking forward to seeing your work. Have a great night.